This video will discuss question 25. Please consider the figure below. Assume OP1 and OP2 are ideal operational amplifiers. All diodes are ideal diodes that can be modeled as ideal open circuits for anode voltage minus cathode voltage smaller than 0.7 volts and its ideal voltage sources with anode minus cathode voltage of 0.7 volts for any positive current flowing from the anode to the cathode. Assume R is larger than 0, C is larger than 0, RA is larger than 0 and RB is larger than 0. All components generate noise. Let's analyze the circuit for oscillations. What is the approximate peak-to-peak value of Vc if only diodes D7 and D8 are used and the other diodes are removed? And then 8 options are given for the amplitudes, including one option saying no stable oscillation can be achieved. Let's have a closer look at the figure. In the question it's stated that only the diodes D7 and D8 are going to be used in the circuit, so all others will be removed. So let's cross them out like this. Under which circumstances will these diodes conduct? Well, we know because of the fact that this is an operational amplifier that the node right over here is always going to be grounded because the positive terminal is also grounded. So because this negative terminal is a virtual ground, the voltage drop will always be from this node to the negative terminal. And that drop can indeed be both positive or negative. That means that diode D7 or D8 can indeed start to conduct. And what happens when one of these diodes starts to conduct? It's given that these will then behave as a voltage source with a drop of 0.7 volts. But what effect will a conducting diode have on the amplification factor of this amplifier? Well, the amplification factor of the amplifier is negative RB over RA, where RB is the feedback resistor, so that's the resistor between the output and the negative terminal, and RA is the resistor between the input and that negative terminal. If one of these diodes would start to conduct, then there would be a short circuit path from the node where VB is measured to the negative terminal of the amplifier. So that means that the resistance will effectively be 0 ohms. In other words, the amplification factor will go to negative RB over 0. And that indeed goes to negative infinity. So a signal that would have an amplitude that's large enough to let one of these two diodes conduct would then be amplified by a very strong factor. And that would cause this oscillator to become even more unstable, because the signal would then be amplified again and again and again by this negative infinity. So from that we may conclude that the introduction of these two diodes would render this oscillator to be useless. No oscillation would be sustainable in this oscillator.